So when your application creates a new thread for every task, you may run into high memory and CPU usage, increased thread creations or destruction cost, and resource exhaustion under heavy load. So to overcome this, we use a thread pool. A pool of pre-created threads are used to execute tasks. So instead of creating a new thread every time a task needs to run, and you can reuse threads from the pool. So this avoids the performance overhead of constantly creating and destroying the threads. So think of an example like web server handling requests. So imagine a web server like a Tomcat or a Spring Boot that receives hundreds of HTTP requests. So creating a new thread for each request will crash the system under load. So the solution will be like thread pool here. So use a fixed size thread pool, say 50 threads. So to serve incoming request. So excess request will wait in queue, and this avoids a memory explosion and unpredictable thread behavior. So this is why we use thread pool. So how we can achieve thread pool in Java? So Java provides Executor Framework, which is available in java.util.concurrent. So which helps in creating and managing thread pools. So there are a couple of key interfaces and classes available here. So there is Executor and Executor Services. So these two are interfaces for a task execution. Then for core implementation, we have a thread pool executor, and to uh, like create a thread and execute those, we have a creators class. So here are some of the options available under executor service to create a thread pool. So we have a fixed thread pool. So here again, we like in all the options or most of the options, we are using executor services itself. Then using the class executors, we are calling the methods. The first one will be the fixed thread pool. Here we are using a fixed threads. Actually, you can see here I'm using fixed threads, that is port. So again, it's fixed here. So the extra task, let's say you are calling 10 threads, and at first we will be using, or it will be calling only 4, or it will be executing only 4 threads, and beyond that it will ask the thread to wait. So extra task will wait in queue if all threads are busy. Like the 4 threads will be executing. After the execution of 4 thread, the next available threads will be executed. Until that it will be idle, or it's in the block stage, you can say. So it's idle for predictable number of tasks, and if you know the number of threads needed, you can go for a thread pool option. So then we have a cached thread pool. Here, instead of new fixed thread pool, you can go with a new cached thread pool. So here it creates a new thread as needed, but reuses previously constructed idle threads, and threads that remains idle for a minute are terminated here. So here no limit on number of threads, and sometimes it cause high memory usage if too many tasks are added. And you can go for this approach if you have a many short-lived asynchronous tasks. Then we have a single threaded executor. Again, single thread executor method you can call. So here only one thread is active at a time, and tasks are executed sequentially in a single worker thread. So this will be useful when you want a task to run in order in a sequential way. Then we have a scheduled thread pool. So it allows delayed or periodic task execution. Here we have a scheduled thread pool, so it will be delayed for a given period of time actually. So it's like a timer, but more powerful, and it's a robust actually. So let's say you need a task to run after a delay or at a regular interval, you can go for scheduled thread pool. So since Java 8, we have a fork join pool. So it's for parallel computation, like it's use divide and conquer, like recursive task. So if you are working with recursive algorithms or large data, you can go with a fork join pool. So once you created all this executor, there are some methods you can or you have to use. That is, so now you have created a pool, and the next task will be adding the threads to the executor. So for that, you what you have to do is you have to call execute a method which will which we need to get all the threads here. So add all the runnable threads here, then it will execute the task, and submit will submit the task that returns the value, and shutdown will initiate the shutdown. And these two approach will help, like it's better to use shutdown or shutdown now to terminate the things, and wait termination waits for task to complete. We have a advanced one, so here you can control every aspects of a thread pool uh, while creating. So you can see here a core pool size and maximum pool size. So this is using a thread pool executor actually. So time to keep extra threads alive. So you can see the period of time, that 60 seconds, that the time to keep extra threads will be alive, and the next will be linked blocking queue. So this is a custom thread executor, so which will you can control every aspects here. So what are the benefits of using thread pools? So you can like thread use reuse, that is no need to create threads again and again, and controlled resource usage and improved performance. You can go for scheduling and queuing as well, and for thread safe environment. So there are some issues also here. So like task queue overflow, like too many tasks, thread pool can't keep up. So in this case, what you can do is you can tune the thread count and the queue size. Like deadlock problem might occur. So that is threads wait on each other. So avoid shared resource unless it is not synchronized properly. Rejection, like sometimes executor throws rejected execution exception. So use custom handlers. So forgetting to shut down, so it cause like memory leak and app won't terminate. So in this case, what you can do is like always, as I mentioned before, like always call shutdown or shutdown now. Um, once you're done with your task. So again, common mistake is not calling shutdown and using unbounded thread pools with infinite task, and blocking task inside a fixed thread pool are the common mistakes which you can avoid. So let me show you a simple example in Eclipse. So here is a simple example of using executor service. So you can see here I'm using executor service and executor. So it is a class, and we have a fixed thread pool, new work stealing pool. Again, there are a number of options available here, so which we already seen. So the first thing, like what I'm using here is like new fixed thread pool. So, I mean, I'm going for a fixed thread pool, so I'm giving only three here. So the example what I am trying to do is here is like just illustration of ticket booking. Okay, so the first thing what we need to do is you have to create a executor service and go with required options. Like here I'm going with a new fixed thread pool. I'm passing account three. Only three pool, like three thread can be executed simultaneously or concurrently. So to execute, to add all the threads, what I'm doing is I'm using the executor and calling execute and passing the threads. So here is the runnable thread which I have used, and I have a constructor which will initialize the customer name. Then I have a run method. So what I'm doing is I'm just printing the message saying whatever the customer name I have passed is booking ticket using thread, whatever the thread name it has allocated, then sleep for a time, like period of time at 2 seconds, then say that okay, ticket is booked. Is just to say that okay, it's a high level thing, like just simulation saying like okay, while booking the some period of time will be taken by the system or for logics and all. So it's just a simulation. So and print the message saying ticket is booked. And what I'm doing is I have created a for loop. So I'll be creating 6 threads here. So only three will be executed at once and three will be remain idle. And once it is done, you can see here it's just shutting down the task, like shutting down the things, and no more tasks will be executed further. So let me execute this. So you can see customer 2 means it will go sequentially like 1, 2, 3, 4 and all, but you can see that customer 2 is booking ticket using thread 3, 1. So at a time, 3 threads will be executed, and you can see ticket booked for customer 1, 2, 3. Again, next 3 will be executed, and booking will happen for that customer. So, and this is not sequential. You can see if I execute multiple times, again 2, 1, 3 got executed, booked, and again 5, 6, 3. It differs timely, and sometimes it like you can see here 3, 2, 1 and 6, 6, 5, 4. It changes every time. It's not a sequential way. Every time you execute, it changes, and you can see here we are calling 3 threads here. We have executed 3 threads, and what happened here is first 2 got executed, and in meantime, what happened is as 3 was in queue, so one take over the thing and it executed. So you can see here the first 3 called, only 2 got booked, and one was in one was in executing stage. So the one which was in queue moved to execution stage, and it booked the ticket. So this is how it happens, like the whatever the pool execution completed, it comes out, and the next task or next thread which are in queue will go to for execution. So this is how a thread pool works. So only fixed number of threads will be executed for a period of time. Once execution is done, the next available queue or available threads which are in queue will go for execution. So thanks for watching.